All right, let's get right into it. For decades, we've been launching these incredible, advanced machines into space, just absolute marvels of engineering. But here's the crazy part. For all their power, they've been stuck using the cosmic equivalent of dial-up internet. So today, we're going to talk about how we finally gave our satellites a proper broadband connection. And it really all starts with this one question. Just think about it for a second. What if every single satellite, from the tiny little CubeSats to the huge Earth-observing platforms, had a constant, screaming fast internet connection? What would that even make possible? This one question, well, it's the key to a massive revolution that's happening just a few hundred kilometers over our heads right now.
But, before we can appreciate the solution, we have to understand the problem. And for satellites, it's a big one. Let's call it the satellite's dilemma. You've got these instruments that are collecting just unbelievable amounts of data, but they're totally isolated, floating around in this communications desert, and they're all struggling to get that priceless information back home to us on Earth.
This quote just nails it. The problem has always been the sporadic and timed-down nature of satellite communication links. For pretty much all of spacefaring history, talking to a satellite wasn't like a phone call, it was more like a fleeting whisper. You had to wait and wait for it to pass over a ground station. You'd get this brief little window to download data, and if you missed it, well, too bad. You just had to wait for it to circle the entire planet and come back around.
And look, this is not a new problem. People saw this coming. Way back in the year 2000, missions like TechSat-21 were already dreaming of having satellites work together in these big clusters. But even then, they knew the huge hurdle was going to be the satellite-to-ground communications loads. Then, fast forward to around 2015, the new space era kicks off, and suddenly, we're just flooding low Earth orbit with sensors. The result? Today, we're creating way more data in space than we can possibly download. It's like trying to drink from a fire hose with a tiny straw.
So if we're creating all this data, how have we been handling it up until now? Well, the old solutions created this massive bottleneck in the sky, and it's been holding us back from really tapping into this flood of information.
The main ways we've done it are with ground station networks, or GSNs, and data relay systems. You can think of the GSNs like a string of lighthouses on the coast. A satellite is like a ship at sea, and it can only be seen and talk to us when it passes directly over one of those lighthouses. Data relay systems tried to fix this by putting a big communications satellite way up high to act as a middleman, but that's super expensive and just doesn't scale well.
And here's where it really hurts, the delay, the latency. We're not talking about a few milliseconds of lag in a video game. No, with these traditional ground station flyovers, a satellite could capture absolutely critical data, say of a wildfire or a hurricane forming, and then be totally out of contact for more than 10 minutes, sometimes even hours, before it can send that life-saving info down. But then, everything changed. Seriously, we saw this revolutionary shift not just in the satellites themselves, but in the entire philosophy of how you build a network. And it all started with a really simple but powerful idea. Bring the network way closer to home.
The difference is just staggering. See, traditionally, those big communication satellites were in geostationary orbit, or GEO, more than 35,000 kilometers away. That distance creates huge delays. We're talking over 600 milliseconds of latency. The absolute game changer was building these massive constellations in low Earth orbit, LEO, just 550 kilometers up. That one change slashed the latency down to about 25 milliseconds. That's a difference you can actually feel.
But just getting closer wasn't enough. The real magic, the secret sauce, was in the hardware. We got these incredible phased array antennas that can steer internet beams electronically without moving parts, and efficient ion thrusters that let the satellites dance in formation. But the absolute crucial piece of the puzzle was giving the satellites the ability to talk to each other. Using optical space lasers, they could now shoot data between themselves, forming a true high-speed data network right there in orbit.
And this right here, this is the new reality. We are no longer thinking about single, lonely satellites passing overhead one at a time. No, we're talking about a seamless, interconnected mesh of data that blankets the entire globe. It's an internet backbone, but in space.
So, once you've built this incredible superhighway in the sky, what's the next logical step? Well, you let other satellites get on it, of course. This is what enables a fundamental shift in how we use every single asset we have in space.
And this new paradigm, it has a name, Mega Constellation Services in Space, or MCSS. The idea is just brilliant because it's so simple. You take these massive internet constellations that are already up there, the ones designed to beam internet down to us on the ground, and you just point at receiver upwards. Other satellites can now become customers, users on this new space internet.
And check out how easy it is. So you've got a satellite in a lower orbit. All it needs is a special antenna, a space user terminal that points up instead of down. It locks onto the nearest mega constellation satellite flying above it, and poof, its data gets zipped through that laser mesh, downlinked to an existing ground station, and straight onto the global internet. It's really that simple.
Now, what's really clever about this is the flexibility. This is not a one-size-fits-all thing. You've got different terminals for different missions. There's a low-end version for a tiny satellite that's just sending back basic health data. Then you have a common case for your typical science or Earth observation mission. And then there's the high-end terminal for the big data hogs, the platforms that need to move massive files.
Okay, so this is all really cool tech. But the big question is, what does this actually get us? What's the payoff in the real world? Well, the results are nothing short of transformative.
Let's just look at the raw numbers here. We are talking about a potential of 5 terabits, that's terabits with a T, of data per satellite per day. To put that into perspective, the old way is like getting a single postcard in the mail. This new way is like having the entire Library of Congress delivered to your doorstep every single day. It's not just an improvement, it's a completely different reality. This means we can monitor climate change in near real time, track wildfires second by second, and get instant imagery after a natural disaster.
But the benefits don't even stop at raw speed. It gets cooler. This dense web of satellites is so powerful and so predictable that it's actually creating brand new capabilities we never even planned for.
Take navigation, for example. You know how an ambulance siren changes pitch as it drives past you? That's the Doppler effect. Well, by analyzing those same tiny frequency shifts in the radio signals from the dozens of LEO satellites visible at any time, we can calculate our position with incredible accuracy. Real-world tests have shown this can reduce positioning errors by over 45%. It's a powerful, completely independent backup to GPS.
So here's the bottom line. This is the crucial point. We are fundamentally changing what a satellite is. It's no longer some remote tool that we just send commands to from far away. It is becoming an integrated, active part of our global information network. Just look at this transition. Yesterday, a satellite was a remote data collector. That's it. Today, it's an active node on the internet. In the lingo of future networks, it can be a user equipment, basically a client, like your phone, or it could even be a GNB. That's the technical term for a 5G or 6G base station. It essentially turns the satellite into a cell tower in the sky, serving users on the ground or even other things in space.
And that really leaves us with this final fascinating question to think about. For our entire history, we've treated space as a destination, a place we send things to. But what becomes possible when space is just another node on our network, as accessible and as interconnected as any server sitting in a data center on the ground? The possibilities, well, they are just beginning to unfold.